Good day, everyone. Mercury. Mercury is unique as it is a metal that exists as a liquid at room temperature. Investigating mercury's liquidity at room temperature leads to a deeper appreciation of chemistry because it demonstrates both quantum mechanical and relativistic theories. Quantum mechanical theories, based on solving the Schrödinger wave equation and understanding the significance of the wave functions that come from this equation, help us to understand modern atomic structure. Purcell, 1991. The square of the wave function can be interpreted as a probability of finding an electron in a certain volume of space given a certain amount of energy. Again, Purcell, 1991. This volume of space with a high probability of finding an electron is known as an orbital. Again, Purcell, 1991. The concept of an orbital leads to our current understanding of the electronic structure of an atom. Purcell, 1991 again. Note the electronic structure for mercury at the top of the board. Xenon, 4F14, 5D10, 6S2. This is per Norby in 1991. Pay particular attention to the 6S orbital, since it plays such a large role when we talk of the relativistic theories of what is going on with the liquidity of mercury at room temperature. Okay. Interestingly, the metallic bonds of mercury atoms are much weaker than the quantum mechanical model predicts, according to Norby in 1991. Relativistic theories predict effects acting on the 6s2 orbital, which make it that mercury can exist as a liquid at room temperature, per Sinise in 2011. When electrons move at or near light speed, relativistic effects occur. Again, Sinise, 2011. One relativistic effect that occurs is that the mass increases as it approaches light speed. This is what's called the relativistic, or what we call the relativistic mass increases. Again, Sinise, 2011. Another such effect is that the orbitals that these electrons have a probability of existing in contract, and their probability density gets closer to the nucleus. Sinise, 2011. All right. Please note the two diagrams in the middle of the board. Okay. As you can see, the top diagram shows 6s probability density plot, and below that a diagram showing the contracted 6s diagram due to the relativistic effects. And you can see they're a lot closer to the nucleus over here than they are here, and it's just the probability density. The relativistic effect is very noticeable here. Okay. So as you can see, the probability density has contracted in the second diagram and is much closer to the nucleus than in the probability density chart of the 6s orbital without the relativistic effects. This means that the 6s valence electrons of mercury are not available for bonding with other mercury atoms because they're much closer to the nucleus of the atom and therefore less likely to be available for bonding to the other mercury atoms, per Sinise in 2011. So investigating mercury's liquidity at room temperature demonstrates both quantum mechanical and relativistic theories that lead to a deeper appreciation and understanding of chemistry. Quantum mechanics predicts the electronic structure of mercury, but it does not predict the weaker bonding that exists with the 6s orbital. Relativistic effects predicts the contraction of the 6s orbital, which leads to the electron spending more time in the nucleus, or rather near the nucleus, closer to the center of the atom, and less time bonding with other mercury atoms. This explains mercury's liquid state at room temperature and marries the two complementary yet very different theories. Any questions?
Do relativistic contractions involve orbitals other than the 6s orbital?
Yes, relativistic contractions of other orbitals does occur. However, because the 6s orbital contains mercury's valence electrons, contractions of this orbital decrease the likelihood for it to bond with other mercury atoms, per Norby 1991.
Why does the wave function need to be squared?
The literal solution of wave function have no physical meaning. However, taking the square of the wave function can be interpreted as the probability density of finding an electron in a certain volume of space if that electron has a certain amount of energy, per Purcell, 1991 also.
Can mercury exist as a solid at other temperatures?
Absolutely. The melting point of mercury is negative 39 degrees Celsius, At temperatures less than negative 39 degrees Celsius, mercury can exist as a solid metal, per Norby in 1991. Any other questions? No? All right, thank you for coming. I'll look forward to seeing you again.